Imagine stepping outside one night to see a star glowing brighter than the full moon, so luminous it casts shadows in the dark and can be seen even during the day. People around the world pause, gaze upward in awe, not knowing they are witnessing the beginning of a catastrophe. That isn't a star shining bright in celebration. It's dying, and in its death, it's about to unleash an energy so destructive it could forever change life on Earth. This is the arrival of a nearby supernova, a stellar explosion that's among the most violent events in the universe. When a massive star reaches the end of its life, it collapses in on itself, and then detonates outward in a blinding flash of gamma rays, cosmic rays, ultraviolet radiation, and intense heat. If such a star were located within 30 light-years from Earth, the consequences would unfold faster than most of us could even comprehend. The first thing we'd notice is the sudden burst of intense light, appearing out of nowhere. It would begin as a mysterious bright spot in the sky, then swell to something never before witnessed by the human eye. But what the naked eye can't see is the true danger. Gamma rays, moving at the speed of light, would arrive in full force. These invisible waves would slam into our planet's atmosphere, stripping away its delicate structure like sand in a windstorm. Oxygen and nitrogen molecules would be shattered apart and recombined into toxic compounds like nitrogen dioxide, which would then begin to chew away at our protective ozone layer. Within days, Earth's natural shield against the sun's ultraviolet radiation would be compromised. Without it, the surface of the planet would be exposed to dangerous levels of UVB rays, which cause cancers, genetic mutations, and devastate the cellular structures of nearly all living organisms. On land, humans would burn under a sun now too powerful to face without full protection, but the oceans would feel it first. Tiny plankton, those microscopic plants floating on the sea's surface and forming the very foundation of the marine food web, would die off rapidly. Without plankton, the ocean's ecosystem would unravel. Fish would disappear. Coral reefs would bleach and crumble. And with the oceans dying, billions of people who depend on marine life for food and income would face a crisis unlike any in history. But this is only the beginning. After the initial radiation, the cosmic rays follow. These high-energy particles, some moving at nearly the speed of light, would arrive over the following months and years. They'd penetrate deep into the atmosphere and even down to the surface. This bombardment would cause a dramatic increase in ionization, turning the skies into unstable electrical fields. Lightning storms would multiply. The magnetic field of the Earth, though designed to deflect radiation, would struggle to cope. Power grids would fail. Satellites would short out. Communication systems would go dark. Everything that modern civilization depends upon, from GPS to banking to weather forecasting, would be crippled or destroyed. On Earth's surface, the ionized atmosphere would cause a reddish-brown haze, blotting out parts of the sky and letting through only distorted beams of light. Air quality would plummet. Plants would struggle to photosynthesize, and agriculture would begin to fail. Famine would sweep across continents. Countries would compete for dwindling resources. Social structures would bend under the pressure. Political systems would either collapse or harden into survivalist regime. And what of the long-term effects? The damage to the ozone layer would not repair itself quickly. For decades, maybe centuries, the surface of the Earth would remain bathed in high levels of ultraviolet radiation. Humans would be forced to adapt or move underground. Buildings might be redesigned with UV-proof materials. New clothing would be created that shields against dangerous rays. Daytime activities would become nighttime tasks. Cities might be built with ceilings, and farming could move indoors into carefully monitored biodomes. Emotionally and psychologically, the event would transform human culture. The sky would no longer be a place of wonder. The bright star, once a marvel, would become a terrifying reminder of fragility. Children would be told stories of the night the star died and nearly took the Earth with it. Art, music, and even religion might shift in tone, centering around the fear of cosmic events far beyond our control. A new respect, or perhaps fear, for the universe would be born. In this world, only the most resilient species survive. Microbes buried deep within the Earth, fish swimming in the darkest parts of the ocean, and humans who manage to build a technological shell around themselves, protecting their fragile biology from a sky that once nurtured them and now seeks to destroy. The scale of this catastrophe isn't just planetary. The energy released by a supernova is nearly unimaginable, enough to outshine entire galaxies for a short time. That blast could reach across interstellar space, crossing trillions of kilometers kilometers, carrying radiation energy and destruction in every direction. If Earth stood in its path, even light years away, it would be like facing the barrel of a cosmic cannon. What makes this terrifying scenario even more haunting is how sudden it would be. The explosion, the radiation, the breakdown of ecosystems, it could all unfold without warning. Even with our current technology, detecting when a nearby star is about to go supernova is extremely difficult. Stars like Betelgeuse, which is over 600 light-years away, are closely monitored because they show signs of being close to collapse. But a star only 20 or 30 light-years away, going unnoticed until the very end, could suddenly detonate and leave us scrambling to survive. This isn't the stuff of science fiction. Throughout Earth's long history, our planet has likely been exposed to such events before. Some extinction events in Earth's fossil record may have been triggered by nearby supernovae. We've simply forgotten, as the damage occurred millions of years ago. But the universe never forgets, and it continues, endlessly churning stars into life and death, with no concern for what might be in their path. If a supernova explosion ever occurred near Earth, the result would be a perfect storm of radiation, climate disruption, technological collapse, and ecological annihilation. It would force humanity to either rise to a new level of innovation and resilience, or vanish into the pages of cosmic history as just another species that couldn't keep up with the universe's unrelenting scale and power. And yet, in all of this destruction, there's a strange beauty. A dying star creating heavy elements that seed new solar systems. A cataclysm that resets the playing field for life itself. The end of one story becoming the beginning of another. Because even in the darkness of a supernova's wake, the universe doesn't stop. It rebuilds. It adapts, just as we must. So, the next time you look at the stars, remember, they are not just twinkling lights. They are engines of creation and destruction. Clocks counting down silently. Reminders that our place in the cosmos is never permanent, but always awe-inspiring.